Here's this printer from CREALITY. Let's try to update the firmware. So this is the USB flash drive that came with the printer itself. Plug it into a card reader. Those folders are already on the USB flash drive. The red LED is flashing, and onto that one we have to copy this update file, which was downloaded from this web address, the firmware update for the printer, CREALITY LD-002R. And here's the download button. If you click on the download button, it will go to creality.com download, and there select Resin series. And there the 002R, and the latest one is this. There's another 002 here, but that does not have the letter R. So double click on that one. That's the zip file on the right side. Enter into that folder and copy all those files into the root directory of the USB flash drive. Root directory means that you don't insert the files into any directory, just simply I'm dragging with the right click of the mouse, copy, and they are outside here, they are not in a folder. Remove that flash drive, it's not powered on yet. Insert it into the USB port of the printer. Now power it on. Wait a few moments until the screen also turns on. Beep sounds. CREALITY. It also has a helping page, chitubox.com, at that address, how to update it. Those beep sounds or the update. Let's tap on system, about, and that's the current version. Back. Let's power it on again. Will it update again? Now there is no beep sound. It was already updated. Here it says that it will automatically update the file, and you will hear the dee sounds, 5 short beeps and 1 long beep. So I will delete those update files from the USB flash drive. Delete. Yes. Let's start Chitubox. Before the update it was mentioning updating the firmware, and now it's not mentioning that one. Now I think it's at the 4th layer, 4 out of 1300. Mamma mia. 5 hours and a half remaining. Jesus. At every layer it reads from the USB flash drive, and that number advances a little bit. Yes. LED is flashing on the flash drive, and it's not at the 4th but at the 5th layer, I think. And it's only 1%. There are a few bubbles there. I don't know if that is bad or not. The light is pretty low here. I don't know if that makes the resin cure a little bit or not. This is just a cardboard. Power is from there. Resin is here. UV sensitive resin. It's clear, transparent, 405 nanometers. Now we are at the 6th layer out of 1300. The interior is not lit. You don't see what is being printed. Only the LED of the USB flash drive and this LCD is lit. Plus there is a red sensor there in the center somewhere. By the way, you have to export it from Chitubox as a CTB file, so the default extension which is given by the program, if you use that one, then the thumbnail of the drawing will not show up. I'm not sure if the file is usable, but CTB makes the thumbnail show up on this printer. So almost an hour passed. We still need almost 5 hours. Layer 200 out of 1300. By the way, it's always moving up and down, as you can see there. As it's making a layer, it's raising it up and then it's lowering it down. You can see the liquid moving inside. That plate is moving up there into the liquid and out of the liquid. It's going up. Now it's going down. That's a transparent liquid inside this bottle. That's the resin on this paper. It's just a little bit sticky. It's shiny a little bit. By the way, I created the drawing in SolidWorks. From SolidWorks I saved the drawing as an STL file. I imported that STL file into Chitubox, and so-called sliced it and saved it as a CTB file. So from STL to CTB, and the printer is using the CTB file. You can remove this cover while it's working. The process is not interrupted. There's a QR code on the top of this one. This is metal, but I don't feel any heat. Neither the flash drive is heating up. Air is exiting here at the back. There's a fan somewhere. Now there's a blue light. That has to be the ultraviolet light, which cures the resin, makes the liquid harder plastic. So when the device is silent, then the light turns on. Now it's curing, now it's preparing the next layer. Now it's curing it again, it's solidifying it, liquid into solid again. So here's the old broken component, and here's the new one which was printed. So the right side is present on this one, whereas it's broken on that one. Plus this has a rib here in the center, a reinforcement, whereas the original one did not have that one. Here's the liquid, the resin. UV wavelength 405 nanometers. So the ultraviolet light at 405 nanometers is curing it, making the liquid hard object. And here's a flashlight which emits UV light. It's just scratched there on the surface at 395 nanometers. 395 versus 405, so it's pretty close, and hopefully it will also help solidify that material. It's visible even on the camera. Already there a few moments from multiple angles, and hopefully it will do something good, make it more solid, less liquid. And that's the finished product. It's not too perfect. Inside the hole, the right side is not too round. There is something on the right side. There are some tiny lines on it. It's still sticky a little bit. Longitudinal lines. This end is slightly damaged because I tried to take it off from there. That side was on the metal surface, on aluminium. That was in the air. The corners are rounded inside there. More lines here. I didn't design it that way, but it's okay. It's not liquid anymore. By the way, this side where the holes are was more sticky than the other side, so let's see if I put the lamp on that side, will that stickiness go away? There is a difference. It's not that sticky. That lamp does the job. It's not sticky. It's just like the other side. Wow, my flashlight repaired my plastic. Now that's cute. It's shiny there in the center, but it's not wet, neither sticky. So having a flashlight like this, ultraviolet, is a good idea. It's curing the plastic, it's making it harder. Make sure the nanometers are pretty close. 405 is on the liquid and 395 is on the flashlight. Ultraviolet UV light. So this part in Chitubox 191 looks like this. It's on that round part. It sits on that one. With the left click of the mouse you can pan it left or right. With the right click of the mouse you can rotate it. Scroll wheel is also panning if you push it down. This is the slicing. That's the entire size which is possible to be printed. And from that I'm using only that one. Slice. Those are the settings. Time 1 hour 58 minutes. Save. To the flash drive. It's a microphone support. Save. That blue thing goes to the right. Right, successful. And we can close it. Yes, quit. So that's on the flash drive. The STL was created by SolidWorks, and I open the STL file with Chitubox and save it as a CTB file, and the CTB is being printed by the printer. So currently there is no liquid inside there. The flash drive is inserted. Let's go here to print. So since there is no liquid, there is nothing to ruin. Neither this is attached. Okay, so there's the drawing, that microphone holder. Tap on that drawing, tap on that one. There's the drawing, that is flashing. Okay, click on that play button. And it's going down, but there is no liquid. It's not saying how much time is remaining. So that is going down. What will happen? 1 hour 59 minutes. Okay, so I should stop it. There's the UV light. Okay, let's stop it. Are you sure you want to exit? Confirm. So I just stopped it. Now it's erasing it. So now I should insert the liquid, mount the plate there and try to print it. So let's move this one higher. Go here to tool. The first one, manual, that up and down sign, and it's set to 10 millimeters. You can set it to 1. So 10 millimeters and up. It goes up 10 millimeters and it stops. You can press it, let's say 3 times, and it stops at every 10 millimeters and then it continues up. Okay, now insert this one. It was already zeroed down once, so the screws are theoretically in the correct position. So here's the resin. On the tool, manual, there's the home. That will sand this part down into the liquid. So home, it's sending it down. Can I meanwhile exit? Yes, back. Now let's go to print. There's my drawing. It enters into the liquid. Ooh, it's pushing it out. Bubbles. Okay. And play button. 1 hour 59 minutes. Let's just cover it. This light is too much for it. Now it went up to 2 hours and 8 minutes. He's cheating. It's at the third layer from 500. I covered it. So the printing is done, but the result is not nice. There's nothing up there. There is something inside there in the center. So no support was added and the object fell off. Printing done, 2 hours and 17 minutes. Let's try to fish out that object using a screwdriver. Oops, that object has no height. When I pour the liquid out from that one here, do not expect the resin to come off at this end, but it will go down and it will come off at that end. What is there in the center? I have to clean off that one somehow. Soap and warm water also dissolves this liquid. Now let's remove this one. Here's this piece of paper and it has resin on it. Now here's a UV flashlight. Will it turn to solid? So currently it's pretty soft. It seems to be harder. And yes, it's hard. It's not sticky anymore. It's not wet. It dried. I got a little bit of resin on my hand, so it wasn't totally dry everywhere. It's not sticky. And it's pretty hard. So you can cure it with a flashlight. Now let's see, warm water and soap. That should dissolve it. And that was created, a 1 millimeter thick object. It's still sticky, it's kind of soft. I have to put the UV light on it. Of course it's useless in this state, but we can play around with it. Really break how fragile it is or how elastic it is on both sides. Will it break? By the way, it's very thin, around a millimeter. Ooh, it seems to be somewhat flexible. It's not bad. Look at that. It seems to be pretty flexible. It's not breaking, at least not now. Only a small portion receives UV light, that blue portion. There we have it. The object is more or less visible. It's covered not to receive sunlight. There's the UV light, by the way. Here's an idea to add a wire around there. The end is here, that small one, and let it drip down. So it's behind this one. You can also cover it. That wire is a little bit thin, but it's more or less okay. And the drop just fell off from the component. Another there. So I washed it with soap and water 2 times. 1 is not enough, maybe 3 is needed, whatever, but let's try with a simple knife. And this part came off pretty easily. It's in the air with one single hand. Look, it's been raised. Whoa, it came off. It's kind of sticky, so I have to put on the UV lamp. You can see the marks there. That's my first time when I'm printing with support. Without support, this 5 mm thick component came out 1 mm thick, and it was sitting on this round shape which is down here. Hold it there, I'm not sure, half a minute, and also rotate it upside down. Of course I have to break off those legs, those supports. Now let's analyze it a little bit. Here on the left side the edge is not straight. It had no support, those legs, and that corner is slightly at an angle. Here we have a 1 mm. You can see the shadow is sticking out. That is fine. It has water on it. Now the corners look better. So I just tried one corner and it came off pretty easily. Like so. I think these support elements were the medium size and they can be broken off with my hand. Now there is in the center. Wow, so that's wasted material, but without this the desired component will not be nice, and it is not nice. So that's another part where it failed. That should be round and it's not. There is no additional material here from that circle, and that is not nice. It's kind of sticky. I have to put the lamp on it. So here's that liquid on the paper. Let's see, is it flammable or not? Set it on fire. Not really. It's burning, but nothing dangerous. Now here's another print, and the bottom, the center, has some marks, so probably the piece was sticking there. Plus, this part here on the right side has broken holding elements, broken supports. They are in the air. That's interesting. So probably the first layer sticked to the nylon which is there, and it could not be lifted, so probably I should use thicker supports. The rest of them are okay. Here I had fewer supports on the right side and they are also broken. Here's an invention, a piece of wire for dripping down this plate. More exactly, I should hang it somehow like that, using that wire. It's already dripping this corner. Yes. So I just attached this plate using this wire, which has the end there, and it's hanging and it's dripping down. Yes, it's dripping, so I don't have to hold it manually. That liquid should come off and fall into the tray. It's dripping from there also and from there. And surprise, surprise, it was not sticking to the middle. As I lifted it up, that sign disappeared. That's one way to let it drip down. Liquid goes down into the bottle. So this plastic thing is for this microphone, Boya MM1, because the original one snapped. So let's see, will it snap right now in front of the video or not, or later? Wow, it did not snap, not now. It looks okay. Wow, it snaps nicely into place. Let's exercise a few times. So that was the original. It's pretty thin. That's the one I made. So the arm is much thicker compared to that one. And from this angle it's also as wide as that part. So of course that snaps because it's very thin. Of course it's also flexible compared to that one. it looks okay. So that is not too nice. That is designed to hold the lower part also, because this one held the top part only from the sides, and of course the microphone could move this way very easily and could deform this very easily. And this one has a support from the back also. Here's this part. It has two tiny 1mm which, wow, they fit in. So the printing is good. Now the next thing is this screw. That hole is too tight, but I think it should be okay. The diameter was good, but since that's an opening, the top portion is not held by anything, so the plastic material is, how it's called, is sagging, it's hanging down. That's why it's more tighter, but I should insert the screw somehow there. And I also made the hole here, which the original one did not have, so theoretically, but not practically. Oops. So that hole was sagging a little bit. The material was sagging because it's not entering. So a thing like this should fix the problem. 3mm is the diameter of the drill bit. That's okay, and that's okay. Fresh plastic. Now that goes inside there. Wow, it's working. Now we can see it. And it's not parallel with the screw. Now it's okay. So that goes into those two openings, somehow like that. The screw is holding it from the top. The screw enters into a metal component. Okay, don't break it. Fresh plastic. Open up that part so that the hot shoe can grab that one. That is sliding because that's its original component, the black part. It stays there, and it has some play. It's not perfect, so oh yeah, it's not perfect. It just snapped. Ouch. So that plastic is not good. It's too fragile, or I have to make it thinner so that it can flex more. Oops. That is fragile. So I need a different liquid, I guess. Or it is too fresh and I already broke it. Just broke there where the part was pretty thick. That is probably because there was no rounding at that corner. So the forces can be concentrated into a sharp corner. Of course it broke there also because there's that hole. This part held it a little bit,